Okay, you should all have this little foldable that you got from class with the little slits already cut. Okay, so you should have 4 little sections here. We're going to review each of the methods for solving a system and then try to get good at determining when we should use each one. So let's take a look at this first little foldable right here, solving by graphing. Okay, so what we're going to do is solve this system. Let's just put a little squiggle here. This is a system. It's 2 equations. It's 2 lines, and we're going to do it by graphing. So what that means is 2 lines are going to share 1 point, and that's what we're going to find for our solution. Okay, so the first one is already in y equals mx plus b form, and the m is 1. Or 1 over 1, that's the m value. The b value is -2. So let's go on the y-axis to -2. And the slope is 1 over 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1. Let's go all the way to the edge of the graph paper. Let's also go left because the solution might end up being over there in that quadrant. So I'm going to go down 1, left 1, down 1, left 1, down 1, left 1. Let's go as many points as the graph paper will allow. And let's draw a nice straight line. A nice line that has arrows on it. Okay, that's only the first line. To solve a system, we have to graph another line. Okay, y equals mx plus b. The m is negative. This is going to be a downhill line, and the b value is 7. So let's start at a y-intercept of 7. We're going to go down 2 to the right 1, down 2 to the right 1. Keep going. It's getting close. Down 2, right 1. Right there. Winner, winner. That is the point that they both share. Keep going. Down 2 over 1, down 2 over 1. Drawing more points past the solution helps the line draw nice and straight. Don't forget to draw the line, put some arrows. Okay, and this is great work, but we have to officially state the solution. The solution is the point that they both have in common, and it's the point 1, 2, 3 to the right, up 1. So an x value of 3 along with a y value of 1 are the numbers that are going to be true for both of the equations. That is how you find a solution when graphing. Okay, let's go to the next part here. Solving a system by substitution. Substitution means to replace. To replace. So we're going to get one of the letters alone, and then we're going to replace that quantity into the other equation. I notice right here that the y variable has already been isolated. This is a great system for substitution. Okay, 2 equations, but one of the variables is already isolated. So let's go ahead and circle the quantity that's equal to a y. That quantity is equivalent to a y. So into the top equation, if I wanted to take y out of the equation, I would have to put something in that was equivalent to him, and that would be a 5x. So let's rewrite the first equation. 4x plus 2. But instead of writing a y, I'm going to write what he's equivalent to. So 5x is the nice little quantity that's going to go in place of the y. You have to write the rest of the equation. Okay, now it's time to show us some algebra skills. 4x plus, this is 10x equals 7. 14x equals 7. Let's be very careful here. Okay, I'm hearing some people say 2. If I divide to isolate x, to get x alone, I have to divide both sides by 14. Okay, x is equal to 1/2. 1/2. Okay, now you're only halfway done. To solve a system with substitution, you have to replace this x value into one of the x locations to find the y. Whatever you circle is the easiest place to do that. Y equals, I'm going to use that part right there to say y equals 5 times whatever x number we got. We got 1/2. 5 times 1/2. So y equals, you could say 5/2. You could calculate half of 5 and get 2.5 if you like. Okay, it doesn't matter if you do fractions or decimals. So the solution for this system would be x value of 1/2 and the y value of 5/2. Okay, solving a system with the substitution method. Okay, now we're going to review the third method, solve by elimination. Okay, elimination means that we're going to eliminate, okay, one variable. And then instead of having two variables, we'll just have one variable. Let's open this flap up and see what we got. Okay, here is our system. It's a system of two equations with two letters. This is a great example for elimination. The x's are lined up, the y's are lined up, the equal signs, and the constants, the numbers. Everything's lined up. Okay, the second thing we have to check, does anybody eliminate? If they don't, we might have to just do some work on it. I'm noticing that a 1 and a 1, they don't eliminate. Oh, but look at this. A positive 1 on the y and a negative 1 on the y, those will eliminate. So this system is good to go. Okay, we can start our elimination. And what we do is we add the two equations together. 1x plus 1x is 2x. The y's are going to eliminate. And then the constants, when I add them together, are 14. Divide both sides by 2. X equals a 7. Okay, we are halfway done. But as with all the methods, you have to find the value of both variables. So let's take the value of 7 and decide where we're going to be replacing it. You can replace it in the top equation if you like. That's got a 12. That's a bigger number. Or we could put 7 into this bottom equation, except then there's some negatives. Okay, so if you don't like dealing with negatives, then maybe we should choose the top equation. You're going to get the same answer either way. Okay, maybe I'll prove that. If I put 7 into the top equation, it would be 7 plus y equals 12. Let's see what answer I'd get. Subtract 7, and I get y equals 5. Are you sure if I substituted 7 into the bottom equation, I'd get the same answer? Let's just show people how that's true. 7 into the x spot minus y equals 2. And then I subtract 7 from both sides, and I get negative y equals negative 5. And then when we divide both sides by negative 1, we're going to get y equals 5. So either way, you're going to get the same y value. Okay, don't forget to state your solution. So the solution is the point. X is 7 and y is 5. 7 comma 5. Hey, have you been writing parentheses? Because they go together. They have to be a point. They're a team. They have to have parentheses. All right, that is a recap of the elimination method. Now, what we want to get good at is choosing the best method. Sometimes one method is easier to do because it's already in that form. Okay, so when would we use the substitution method? It's a great time to use the substitution method. It's a good idea to use substitution when one variable is already isolated. If one of the variables is already alone, substitution would be very easy to do because it's already started for us. Okay. Elimination is great, but it's not always the best one to use. It's really good to use elimination when the equations are in standard form. When they're in standard form, okay? What does that mean? It means 2x, the x's are first, and then the 3y, the y's are next, then the equal sign, and then the constant. So if they're all lined up, ready for elimination, that would be a good thing to do. When the equations are in standard form and something eliminates. If something eliminates automatically, I would definitely recommend this method. Okay, graphing is good, well, if you have graph paper, of course, and it's good when the equations are in slope-intercept form. When they're in slope-intercept form. Okay, do you know what form that means? That means that the equations are y equals mx plus b. If they're already in that form and I don't have to rearrange, then that would be a good time to do graphing. Okay, we're going to look at some equations here and they're going to tell me which method would be the easiest based on how it's set up. Okay, so let's take a look at number 1. Here's a system. I don't think graphing would be good, so let's throw out graphing. Are they all lined up ready to go for elimination? Not really. But I do see that the D is isolated, and I could very easily replace the quantity 4C into that D spot. Number 1 would be a great time to use substitution. That would be fast and easy. Okay, and I'd probably get it right then. All right, let's take a look at the second system. They are not ready for graphing. No, not ready. Goodness, I'm noticing how x's are lined up, the y's are lined up, the constants are lined up. And I'm noticing that the x's, look at this, they already eliminate. They already eliminate. This would be a great time because, boom, look at that, I'm halfway done with the work, to do elimination. That would be a great system for elimination. I kind of want to finish the problem just like that. Okay, and number 3, y equals, it looks like they're in y equals mx plus b form. Okay, so we could definitely do graphing here. The thing is, what if you don't have any graph paper? Okay, this would also be a really good time. I could take this quantity right here and I could substitute in for y. Okay, that would be a pretty easy substitution. That quantity in for that y, and then the solving's not so bad. So I'm going to say graphing as well as substitution. Substitution, okay? Especially if we don't have any graph paper. Okay, I hope this helps explain the 3 methods and which one would be best to use just to make your life easy and have less work. All right, make sure I get to see this tomorrow. Thank you.